So good evening.
Good evening, sir.
Yes, I believe this is a new class that I believe we are covering. We are now into module 3, and we will be covering blind chemical science concepts 3. And so to begin our section, we will be covering Boyle's law. Okay, today we will talk about Boyle's law. Okay. Now, when you're talking about Boyle's law, we are going to do 3 things today. That number 1, we will define Boyle's law. Then we will demonstrate Boyle's law using a balloon. Okay. And then that thing, we will calculate problems involving Boyle's law. That means these are problems with variables, pressure and volume. So we will be finding either of the variables given known variables. Right? So that means we'll be calculating unknown variables of P or V from known variables. Yeah. Unknown variables of B and V from P, that means P or V from, you can say from what I mean by known variables thereof is that you are calculating a known variables of P from known variables of P and V. So rather than repeating myself P or V, I just say thereof. You know what I mean by this?
Yes.
Aha. So I believe it's when we're talking about Boyle's law, we'll be dealing with pressure and volume. I believe this isn't the first time you have met with this concept. So I'd like you to define for me what pressure is and what volume is. So, yeah, please tell us what pressure is.
Pressure is the force always acting per unit area.
Very good. Pressure is force per unit area. So that means we are dealing with force and area. So, if you may, Bonus Steve, please define for us what volume is.
Volume is the amount of space
Yes.
an object or substance occupies.
Very good. Volume is the amount of space that a substance occupies. Right?
Yes.
The other thing, so let me write here. You have some key terms there. We see you have defined pressure, volume. The other thing I'd like us to define is an inverse relationship. What do you understand by an inverse relationship? Yes.
Inverse relationship simply means that both of the variables occurs when occurs not in a direct manner, but
Very good. That's a good attempt. So, do you have? Can you, if you may try?
It was. It's like a variable. Is when one increases, another reduces.
That's a good try.
Yeah.
Okay. So, what an inverse relationship means? It simply in layman's language. When one value is increasing, the other value is decreasing proportionally.
Yeah.
Right? Yes. So now when you have defined this difference, inverse, see, once you define these three things, we can go ahead and define Boyle's law. Right? So using these two concepts, I define Boyle's law. And Boyle's law is defined as the pressure of a unit volume of gas is inversely proportional to its volume at constant temperature. Okay, so I write the definition. The pressure, and note it's the pressure of an ideal gas. And we can write this. We can write this as P 1 over V. Okay.
Yes.
So now that we understand this concept, whereby the pressure is increasing and the volume is decreasing, I'd like to demonstrate this concept using a balloon. If I take this balloon and blow air into it, you see it has a given volume V. Okay. After I increase its external pressure, its volume has decreased. Right? So we may continue increasing the pressure, and the volume will continue increasing until the balloon cannot hold any more pressure. It will burst due to excess pressure exerted. Have you understood that demonstration?
Yes.
So, very good. So, to express this relation mathematically, we can write it as follows. P1 V1 is equals to P2 V2. Okay? At a constant temperature. Is that okay? So I'd like you to do a very simple calculation, and then I'll leave you to do it. I'll leave you with an assignment. So let's do one example. A balloon contains 2.0 liters of gas at a pressure 1.5 atmosphere. If the balloon is compressed to a volume of 1.0 liters while keeping the temperature constant, what is the new pressure? Let's do that. we are saying that balloon has a volume of 2.0 liter, right? At 1.5 atmosphere. So we are being asked when the balloon is compressed to 1.0 liters, what is the new pressure? So we can have a relation P1 is equals to P2, whereby pressure 1 is 1.5 atmospheres, and then we multiply it by the volume 2.0 liters is equals to the unknown pressure times 1.0 liters. So that means the new pressure is equal to 1.5 times 2.0 divided by 1.01. Can someone do for me that calculation very quickly and tell me what is the new pressure? It's not 1.01 rather, it's 1.0 liters. Yes, you divide by, what's the new?
3.
Yes, here go. The new pressure is 3.0 atmospheres. Are we together?
Yes.
I'd now like you to try a different example as your assignment. Has everyone written up to this point?
Yes.
I'd like you now to do the following assignment. You can say that a balloon is compressed at 1.0 atmospheres with you can say 2 liters of gas. What is the new volume of the gas? If the balloon is compressed to 2.0 atmospheres, I'll give you this as your assignment for next class. So I'd like you to take a piece of paper and then write for me what you understood in 1 minute. Yes, write for me whatever you have understood today and what are the challenges. Maybe what are the barriers to your understanding of this concept. And I'll analyze them. You can give these papers to me. I'll go analyze them. Yes, these were the objectives. Okay, this is your assignment. Thank you very much. Have a good day. We will meet next week. Thank you.